The COVID-19 pandemic has sparked immense innovation, and now some of the technologies that were developed to fight COVID are being repurposed to take on other public health challenges. I recently had the chance to talk to the brilliant Dr. Ali Zarei-Baygi, and he explained to me how devices that were developed to track COVID in wastewater could now be used to test the integrity of membranes for water reuse. If you've been following the evolution of water reuse technology, you'll be fascinated by these R&D efforts. Check it out. Why do water reuse experts want to or need to measure whether viruses are making it through a membrane?
Because of the water scarcity all around the world, the water reuse projects are emerging, specifically here in the United States. There are new regulations coming out for direct potable reuse project, and one of the main aspects of this new regulation is pathogen removal. For example, in California, the new regulation for direct potable reuse project requiring 20 log removal of viruses, which is even more strict than drinking water. So to get this 20 log removal of viruses, we need to put this different treatment process to reach this 20 log removal of viruses, and membrane filtration as an essential treatment process in both indirect and direct reuse project. We know that it can remove viruses and pathogens, but right now in a state like California, there is no virus log removal credited to membrane filtration. So what we are trying to do here is to prove that membrane filtration can remove viruses, so we can get credit for virus removal by membrane filtration and reach that 20 log removal value that new regulations require.
Tell me about how we have traditionally done this analysis, so sort of the old school way of assessing whether you're getting removal of viruses. Can you talk a little bit about how culture-based methods work?
So the traditional method, as you mentioned, is culture-based method. In culture-based method, we are trying to grow the viruses in a nutrient media. The problem with culture-based method is that, first of all, it's time consuming. It takes days to weeks to get the result back. Second, it's not sensitive. So for example, if you want to quantify viruses in membrane filtrate, you have to take a large volume of the membrane filtrate, like 1,000 liter, to be able to get reliable data. And then using culture-based method, we cannot grow all bacteria. There are only a few of the bacteria or viruses that can be cultured using culture-based method. And the reason is that we still don't know the exact nutrient condition for these viruses to grow them.
With an eye towards surmounting these challenges, you and your colleagues are now working with qPCR testing. Can you explain a little bit about this technology and why and how it's really taken off in the past year or so?
The advantages of molecular biology method like PCR is that, first of all, we can quantify all viruses. It's not like culture-based method that we can culture only a few of the viruses. We can quantify all viruses using molecular biology and PCR method. Second, it's much more sensitive compared to culture-based method. We can get reliable data with only using 10 liter to 100 liter of membrane filtrate compared to around 1,000 liter of membrane filtrate that we need for culture-based method. And then the turnaround time is around 6 to 8 hours compared to days to weeks on the culture-based methods.
Wow. I mean, obviously, that's a huge difference. I know you and your colleagues have been working with the LuminUltra GeneCount device for qPCR testing, and this is a leading device used for the measurement of COVID-19 in water. Can you talk a little bit about how you've used that device to test for an array of different microorganisms?
Here at CDM Smith, we modified the programming software of LuminUltra GeneCount technology to be able to quantify viruses and viral surrogates that are important in water reuse project. The first phase of our experiment was happened around 6 months ago, where we tried to quantify a few viral surrogates using the LuminUltra GeneCount technology in an advanced water reclamation facility. So we collected sample before and after ultrafiltration, and we were able to quantify the log removal value of the viruses using ultrafiltration.
Specific to this LuminUltra device, what advantages does it offer relative to older or other qPCR testing devices that led you to want to experiment with it and use it more widely?
So one of the main advantages of this instrument is that it's portable. So we can take it to the field with us and measure viruses directly in the field. So we don't need to take samples, send it to a commercial lab, and get the result after a few days. And that's not the only advantage. It's much more cheaper compared to the commercial qPCR instrument. So it's gonna make the whole process cheaper.
How would you see this possibly scaling in the future?
Right now, using the qPCR method that we are doing here at CDM Smith, we make it a portable method so we can use it in the field and we can get the result, the log removal value of the viruses at the same shift that we collected the sample. But in the future, I know that it's going to be faster. For example, right now, we are collaborating with Professor Mike Hoffman from Caltech in a Water Research Foundation project to develop a new method that can do this, that can quantify viruses in less than 1 hour. And it's even going to be cheaper than qPCR.
Wow. Okay. Well, I look forward to hearing much more about that in the future because this is completely fascinating development and just really cool work that you're doing. I thank you for being here today. It's been so cool to talk to you about this stuff.
Thank you for having me.
If you enjoyed this discussion and want more conversations with the brightest minds in the environment and infrastructure, please like and subscribe to our channel. And if you're interested in the latest developments in COVID wastewater tracking, the Louisiana Department of Health recently launched a $19 million program to both monitor COVID-19 outbreaks and to create a platform that protects public health. And all of this is supported by Trinex's Epicast software. For more info, click the link below or check out Epicast at trinex.io/products/Epicast.